Okay, so you watched a video about climate change, and I'm sure Bill Nye does a much better job than I do explaining about climate change. But again, why is it a problem if we get more carbon dioxide? It's not a dangerous pollutant, but because it absorbs that radiation, it doesn't allow the heat to go back out. We got all these changes in CO2 levels, okay? And that carbon dioxide, remember, anthropogenic, comes from people. It's primarily from burning coal and oil and fossil fuels, okay? And like you said, some people will tell you it's a naturally occurring thing. It is, except right now we have too much. We've put too much in there and it's not. If you look at this chart, this is the amount of carbon dioxide in the air. Okay? Yes, it goes up and down, and it used to go like this, but now it doesn't anymore. You can see how it's increasing. And we've had, you know, of the last 10 years, I think 8 of them have been the hottest years in record. So it's getting warmer and warmer and warmer and warmer. And this is the carbon dioxide that we're putting in the air. So something needs to be done about it, or we're going to have some problems. Okay. All right. So another thing we talk about when we talk about um, environment, chemical environment, is our water. Okay. We know that water, normally we store it in ice and it melts and it goes through, we've talked about condensation and deposition and sublimation and, evaporation. It's a cycle. And, up here it rains or it freezes, it melts, it goes in the groundwater. This is where we get most of our drinking water. Okay. Or it gets into an ocean and it just goes around and around. I'm sure you guys know the water cycle. Okay. Most of the process depicted here, sorry, depends on the phase changes of the water. And we've talked about phase changes before. Again, we've got gas, liquid, solid, okay, the phases of water. Okay. So we know that most of our water is in the ocean. Okay. We don't have very much fresh water. I mean, it seems like we do if you look at lakes. And I mean, if you've ever looked at Lakes Kakawee, you think we got a lot of water. Well, that's relative. But 97.2% of all the water we have on Earth is in the ocean. Okay. So the oceans are pretty vast. They have a lot of other things besides just water. They have a lot of very important compounds and minerals. Okay. It's a source of salt, sodium chloride. Bromine is another one they get out, bromine salts, magnesium salts. These are things that we need for all kinds of stuff. We use salt a lot and other kinds of salts in industry. We use them in cooking. We use all kinds of stuff. So we get a lot of them from our ocean water. Okay. One of the most important things that oceans do is they absorb carbon dioxide from the air. Okay. So because they're getting warmer, if you remember when we talked about solutions and solubility, with gases, the colder it is, the more it absorbs. So because our oceans are getting warmer, they're not absorbing carbon dioxide like they used to. Plus, they're not holding on to oxygen anymore. The gas is escaping. So that's one of the reasons why we don't want our oceans to get warmer. Okay. And here's some of your things that you'll find in seawater: chlorine, sodium, sulfate, magnesium, calcium, potassium. So they're a great source of a lot of other minerals. So it's not just water in the ocean. We use them for a lot of other things. Okay. Now, fresh water, the stuff that we drink, the stuff that we use, 0.6%, not even 1% of the water on the planet is fresh water. Okay. In the US, okay, 41% of our fresh water is used for agriculture. Okay. Watering plants, animals, cattle, chickens, whatever, all these things that we need for our food. The nice thing is we use 39% of our water for hydroelectric, but the nice thing about hydroelectric, it just goes through like a dam or whatever and turns a turbine. We don't really do anything to it, so that's kind of nice. We're not messing with the water, okay? Industry uses it. We have household needs. We need to, drink it, flush our toilet, wash dishes, all that good stuff. And then only 1% of all the water we use is drinking water. So you can see very different things using up the water. Okay, so the use of water adds dissolved minerals to the water. Okay, so as you flush it into your system, you're going to add human waste to it, soaps to it, phosphates, sulfates, and again, it gets more and more expensive to clean that stuff out and to guarantee that we're really lucky in the United States because we have clean water. Once in a while you'll hear about E. coli affecting our water or whatever. But it's not like if you look up third world countries and all the issues they have, oh, it's awful. All the things that, can you imagine not being able to get drinking water, clean water? And that happens a lot in a lot of countries. Okay. Groundwater is where we get ours from. Basically, we take in groundwater, we send it through our little treatment plant, and then we drink it. So it's under the soil. We have lots and lots of aquifers. When our aquifer goes dry, then you're in trouble. Okay, then you got to look for other ways. Any of you that have well water, it depends on what aquifer you get into, what kind of water you have. It might have lots of minerals. It might be really good water. It might be really salty water. It might have a lot of iron in it. It just depends on the aquifer. Okay. Approximately 20% of the world's fresh water is in groundwater. So we have a lot of water below us. Okay. When used, these sources of water are not readily regenerated. It takes a long time for the water to soak down and get into there. So there's always issues about that. Not so much in North Dakota. I know there's huge issues in Texas about people taking too much water out of the aquifers. Because one thing is, if you take a lot of water out of the aquifers, the ground actually sinks. You get sinkholes. Okay. So, and you need that water. And so you got to be careful. If it's, if you're in a drought area, you can't use up all your water because it takes forever to replenish. Okay. So, and not all of it is potable, which means drinkable. Okay. Sometimes you get ions and rock formations. You can end up with poisons in it. Like, I know I have a lake cabin and we have a lot of iron in our water. It's just nasty. You wouldn't want to drink it. It stains and yeah, but it's not dangerous. Too much iron in your water just kind of smells funny. It looks funny. But if you drank it, it would hurt you. But you really don't want to drink water that has arsenic in it. And anything, this happens in like South Dakota. They have a lot of arsenic in there, like in the Black Hills. Some of it comes from the mining that they do, but some of it is just naturally occurring. So you got to be careful. If you have well water, you need to get it tested to make sure it's okay. Okay. We talk about dissolved oxygen because we talk about solubility. And remember, the cooler the water is, usually the more oxygen it has in it. And again, because solubility with gases increases as the temperature goes down. So it's an important indicator of water quality to check out the dissolved oxygen in it. They're just little meters you can stick right in the water and it'll tell you immediately. It's a test that you want to do right on site. You don't want to scoop up some water and take it back to the lab because during that time you've lost oxygen. So whenever you do a dissolved oxygen, if you're testing the water quality of a lake or whatever, you want to do it right on site. Okay. They also have aerobic bacteria, which is breaking down things. Well, if you have in this little area right here, you can see there's a lot of plant material that has to be broken down. And when things get broken down, they need oxygen. So you got to be careful, when you get too much of this excessive growth, okay? A lot of algae, things like that. And the other thing they do is they block the sun from getting down into lower levels to break things down because you need sunlight as well. So when you have excessive amounts of biodegradable matter, then you don't get the life, you're going to get things not growing in there eventually. And you're going to get a lot of animals dying, fish dying. You've heard of fish kills before. Sometimes it happens in the spring when the lakes turn over and there's not enough oxygen. But there's all kinds of things that can mess with your water amount. One of the things too, if you have a lot of anaerobic oxidation occurring, a lot of bacteria, it'll give off some pretty nasty smelling odors. One thing we always worry about, especially around the reservation, is the blue-green algae. It's shut down Belcourt Lake a couple of times, okay? If you get that growing in your lake, you don't want to eat any of the fish that have been in. You don't want to be in there because it's dangerous, okay? Whenever this happens, okay, whenever you get excessive plant nutrients growing, it's called eutrophication, okay? And you're actually going to do an activity after this with it to see, but it's excessive dead plant matter in the water. It's kind of a naturally occurring thing, but it takes, thousands of years for it to naturally occur. What we've been doing is we've been putting things like sulfates and phosphates from fertilizers that we put on the land. It gets washed off into our lakes and it causes excessive growth. I mean, when you put nitrates on the land, it makes your plants grow better, your crops. Well, when it gets washed off into the water, it makes them grow faster as well. And you don't want all that excess growth because then when it grows, but then it dies, and then something's got to break it down and it takes away all the oxygen. So you don't want to speed up eutrophication. It's not a good thing, okay? when we have water, most of the time, there are a couple of things we have to do with it. We have to purify it. And if it's ocean water, we have to take the salt out of it. Desalination, it's called. If we have seawater with a lot of salt in it, you can't drink it. Okay. Remember, your normal body fluids are 0.9%, less than 1% salt. Seawater is like 5-6%. So if you drank it, like if you were stranded in a boat in an ocean and you drink ocean water, it would not quench your thirst. Okay. They use reverse osmosis to get rid of the salt. Again, if you go to the store, if you have the big jugs that you go get water, drinking water, and you put in your quarters and you fill up your jugs, that water's gone through reverse osmosis. It moves against the gradient and it actually takes out the salt particles, that's not normal. Okay, that requires energy. It's reverse osmosis. It's going against the flow. Okay, water naturally flows through that semi-permeable membrane. And again, we talked about this before with osmosis. And it goes from low salt to high. Well, we want it to be reversed. We don't want it to be even. We want to get rid of the salt concentration. So we apply pressure. And you can probably calculate that if you remember from the first chapter, we did osmotic pressure. But we can force the water back through the clear water through the membrane. Okay, but again, it takes energy. You purify the water. It's a good process. And again, when you go to Walmart and you stick your jugs in there and you put your quarters in there and you get that water's gone through reverse osmosis. Okay, and you can see this a little bit, some of the filters and how they do it. But again, this is for seawater. Okay. Most of the reverse osmosis water that we, put our quarters in to buy is just water from whatever town you're in, and then it runs it through the process. It gets rid of some of the icky smelling stuff. Like in bottled water, we have tons of iron and magnesiums and salts. It just doesn't taste very good, and it's very, very hard water, so it gets rid of some of that, so it tastes better. Okay, all right. We have water purification. Okay. When water goes to a municipal water treatment plant, and the water treatment plant in Belcourt is down by where you turn to go to Shell Valley, but you have certain steps you have to go. First things you got to do is you got to filter out the large particles, and then they add calcium oxide and aluminum sulfate. They'll add to it, and they'll like react with the smaller particles, and it'll settle down. One of the things that's really important is to aerate it like an aquarium. You got your bubbler going. That helps put oxygen in there. Well, you got more oxygen in there, and then oxygen's going to help break it down. They'll add ozone or chlorine if it's drinking water. Okay, most of the time it's chlorine. A very small amount, but chlorine is a wonderful disinfectant, so it helps kill any bacteria that's in the water. Okay, here's a kind of a smaller scale version you can see of, but this has to be done in order for your drinking water to be safe to drink, because otherwise you're going to have stuff in there that could, if you get E. coli in there, that's not going to be good. We've had a couple outbreaks, I want to say in Rolette, they've had some issues with E. coli in the water. So that's what a municipal water treatment, and again, those are facilities. Now, if you're talking about wastewater, like your sewer water, we use lagoons. Okay, that's a different system. Okay, you're not going to take that water. We're letting that water sit, and we're letting nature filter it and put it back in the groundwater. That water's not treated. It's just basically allowed to sit and, just kind of let the sediment go and then filter back down and let the ground be our filter. But this picture here is if we were going to drink it. Okay. Here's one. Oh, and I have one of these life straws too, but it's at school. There are some things called life straws, because remember, I said like the U.S., we're really lucky. We're very fortunate that we have clean water to drink. These life straws are something that they bring to like underdeveloped countries that have a lot of issues. Look at this nasty water, and she's drinking it with a straw. I don't know that I would do that, but there is the carbon filters. There's iodine that takes the bacteria and viruses out. There's like little sieves, little filters, like screens that keep the debris out. And supposedly, and I have one of these, like I said, at the school, but it has layers. So they have big layers, just get rid of, just mechanically get rid of the chunks. And then they have iodine to kill viruses and bacteria. And then they also have charcoal that helps get rid of them. So suppose you can drink, and this is something that they're trying to do, get to people so that they can have fresh drinking water. Okay, so that's it for today.